Welcome to the DIY Honda Garage channel. The error code P0442 indicates that the vehicle's evaporative emission control system, EVAP, has detected a very small leak in the system. The EVAP system is crucial for preventing fuel vapors from escaping into the atmosphere, thus reducing harmful emissions. Components involved include the fuel tank, fuel vapor lines, and the EVAP canister, which is usually located in the rear of the vehicle adjacent to the fuel tank. It utilizes various sensors, like the fuel tank pressure, the FTP sensor, to detect leaks and ensure that the system operates efficiently. Diagnosing this code requires special tools to test for vacuum and pressure leaks, highlighting the critical nature of not exceeding specified measurement thresholds to avoid damaging any components. Understanding this error is vital for maintaining emission standards and overall vehicle performance. The DTC P0442 points to a malfunction in the EVAP system, which is designed to capture fuel vapors from the gas tank and route them to the engine for combustion. Its main components include the fuel tank, various vapor lines, the EVAP canister, and the FTP sensor. The FTP sensor plays a pivotal role by monitoring the pressure in the fuel tank and sending signals to the engine control module, ECM. If leaks are detected, these signals trigger a fault code, such as P0442. Typically, the EVAP canister is situated near the fuel tank, often towards the rear of the vehicle, making it accessible for diagnostics, but sometimes challenging for repairs due to tight spacing. Having a clear understanding of these components and their functions is important for effective troubleshooting and repair. There are several factors that could cause the DTC P0442 to trigger. First, a blocked or restricted vent hose may prevent the proper flow of vapors, leading to a pressure imbalance that triggers the fault code. Examining this vent hose is crucial, as blockages can often be found due to debris or corrosion. Additionally, faulty components within the EVAP system, such as a defective EVAP canister or FTP sensor, can lead to erroneous readings and accidents. Loose or corroded electrical connections at various points in the EVAP system could also contribute to the fault, especially in high vibration areas of the vehicle. Understanding these possible causes allows technicians to prioritize their troubleshooting steps effectively. The presence of the DTC P0442 often manifests through several symptoms that the driver may notice. The most immediate sign is the illumination of the check engine light, CEL, which serves as a warning of issues requiring attention. Additionally, if the vehicle is taken for an emissions test, a failed result may occur due to the malfunctioning EVAP system, as it does not meet environmental standards. Drivers may also experience poor fuel efficiency when the EVAP system is not functioning correctly, leading to increased fuel vapor loss. Keeping an eye on these symptoms can assist in the early identification of issues related to the EVAP system and lead to more efficient diagnostics and repairs. The first step in troubleshooting the DTC P0442 involves verifying the problem through a series of systematic checks. Begin by turning the vehicle ignition to the on mode without starting the engine, ensuring all electrical systems are active for testing. Next, connect the Honda Diagnostic System, HDS, tool, which facilitates communication with the vehicle's onboard computer. Clear any existing diagnostic trouble codes to start fresh, allowing for accurate readings during subsequent tests. Once this is done, select the EVAP test option in the HDS inspection menu and perform the function test. Depending on whether the test results indicate an OK or a failure, you can determine the next course of action. In step 2 of troubleshooting, one must inspect the EVAP canister vent hose. To do this, start by removing the right front floor undercover, granting access to the relevant components. The vent hose should be checked for any sign of blockage or restriction, which would prevent vapors from circulating correctly. It is crucial to visually and physically inspect this hose, as even minor blockages can lead to significant pressure issues within the EVAP system, subsequently causing fault codes to trigger. If you do find a blockage, it is essential to remove it. If the hose appears compromised, you may need to replace it entirely to ensure proper function. For step 3 of the troubleshooting process, focus shifts to the fuel tank vapor recirculation tube. Inspect this tube for any poor connections, which could lead to leaks, and examine it for signs of physical damage that could impede its performance. A faulty tube will fail to direct vapor back into the intake system correctly, leading to pressure issues within the EVAP setup. If the recirculation tube is found to be damaged or improperly connected, you may need to replace it or address any compatibility issues. In this case, being meticulous in visual inspection can save time in diagnostics, as these components are vital for maintaining a well-functioning EVAP system. Moving on to step 4, the focus is on the EVAP canister purge valve, a crucial component in managing fuel vapor flow. First, remove the valve while keeping its connector and vacuum hose attached for the initial checks. The next step entails disconnecting the vacuum hose from the valve and connecting it to a T-fitting attached to a vacuum gauge and vacuum pump. Slowly apply about 2 kilopascals of vacuum. Monitoring its ability to hold vacuum for a minute is essential. If the valve fails this test by not holding the vacuum, it indicates a leak and that the valve must be replaced. This step is critical, as a faulty purge valve can dramatically affect the entire EVAP operation and lead to recurring error codes. In step 5, you will diagnose possible failure areas further, starting with the fuel vent tube. Begin by turning the vehicle to the off mode to safely make adjustments. Then, disconnect the fuel vent tube from the EVAP canister and seal the EVAP canister port to maintain a closed system for testing. With the T-fitting and initial vacuum equipment removed, attach the vacuum gauge to the purge line hose. Turn the ignition back to on mode and conduct the EVAP test selection from HDS. As you apply vacuum, monitor the FTP sensor for a voltage reading. If it fluctuates more than 0.2 volts indicating a leak, further diagnostics are required. This process ensures that you can pinpoint the source of the issue accurately. Step 6 requires checking the functionality of the EVAP canister vent shut valve. Begin by selecting the EVAP test in the HDS and proceed to implementing the EVAP CVS off function for testing. Disconnect the vent hose from the shut valve port and ensure to plug the end to prevent any leakage. Similar to earlier steps, you will apply vacuum to this hose until the FTP sensor indicates a reading of 1.90 V. Monitoring the sensor's voltage is critical. If it increases by more than 0.2 volts within a minute, it confirms that the shut valve is functioning correctly. However, if it does not, then the valve needs to be replaced to restore the system's integrity. In step 7, the focus turns to the EVAP canister purge line leading to the purge valve. You'll want to carefully inspect this line for any signs of poor connections or physical damage that could be responsible for leaks. A compromised purge line will fail to maintain pressure, leading to ongoing issues with the EVAP system operation. If faults are found in this line or the canister itself, it's imperative to replace them, since these parts directly impact emissions control. Ensuring the components are in good condition is essential for the overall performance of the EVAP system and to avoid continued trouble codes. Step 8 involves a visual check of the fuel fill pipe and the fuel tank vapor recirculation tube for any poor connections or damage. Any issues in these areas can lead to significant leaks, causing symptoms similar to those indicated by the P0442 code. Begin by selecting the EVAP CVS off mode through the HDS and conduct a thorough inspection of the connections and integrity of the pipes. If any damage is identified, such as cracks or corrosion, it is essential to replace the affected parts immediately. Maintaining a leak-free connection is vital for the sealed functionality of the EVAP system. In Step 9, you'll evaluate the shutoff valve, which plays a critical role in managing fuel flow and vapor escape. Start by removing the misfuel inhibit device for easier access to the valve. Check the main flap of the shutoff valve to ensure it is closed properly, as an open flap allows vapor to escape, resulting in a failing EVAP system. If you discover the flap is not in the closed position, this is a clear indication that the unit must be replaced. Reinforcing proper valve function is crucial for maintaining the overall integrity of the fuel system and ensuring no escape of vapors. The final step, Step 10, necessitates a careful examination of the flap seal on the shutoff valve, along with the mating surface it rests against. A damaged or missing flap seal can lead to significant leaks, impacting the EVAP system's operation and causing error codes. If you find any defects, replacing the entire main flap unit is essential to restore proper sealing. Additionally, it's worthwhile to assess the O-ring on the fuel tank unit, as this can also contribute to pressures within the system. Proper sealing is paramount for ensuring efficiency, emissions control, and the integrity of the entire fuel system. Once all necessary repairs or replacements have been made per the troubleshooting steps, it's critical to perform a final verification of the repair process. Start by clearing all DTCs using the HDS to eliminate any previous fault codes that might interfere with new diagnostics. After clearing the codes, conduct a road test to monitor the vehicle's performance and confirm that the check engine light remains off. Pay attention to the functionality of the EVAP system during different driving conditions as part of the verification process. Ensuring everything is operating as intended is essential to validate that the issue has been resolved and to prevent the recurrence of the P0442 code. Preventive maintenance is essential to minimize the risk of future issues related to the EVAP system and error codes like P0442. Regular inspections of the EVAP components, including hoses and valves, can help identify potential problems early and mitigate costly repairs down the line. Additionally, ensuring that the fuel tank remains clean, free from debris, and well-maintained contributes to the long-term efficiency of the entire fuel system. Make it a habit to check for loose or corroded connections, especially in high-vibration areas, as these can lead to malfunctioning components. Proactive steps not only enhance the vehicle's performance, but also help in meeting emission standards. In conclusion, understanding the significance of the EVAP system is crucial for every Honda Civic owner from 2016 to 2021, as it plays a pivotal role in emissions control. Following the outlined troubleshooting steps for DTC P0442 allows technicians to efficiently diagnose and repair any underlying issues. Keeping an eye out for common symptoms can facilitate early detection and remedial action, ensuring that the vehicle remains compliant with environmental standards. Regular maintenance practices are equally important, as they help prevent future problems, maintaining operational efficiency and extending the vehicle's lifespan. Emphasizing these aspects ensures a well-functioning and eco-friendly driving experience. Please like and subscribe to the channel. See you next time.